It's my great pleasure to join this ESGRS webinar, but this time as a speaker. So the title of today's presentation is Earth Observation Products and Services from Concepts to Applications and Beyond. So I'll start by giving you a bit of introduction about Mohammed bin Rashid Space Center, its vision, mission, goals, projects, and initiatives. Then I will elaborate on the concept of Earth observation and remote sensing, along with its valuable products and applications. Okay. So the story started back in 2006 when Sheikh Mohammed bin Rashid Al Maktoum established the Emirates Institution for Advanced Science and Technology, EAST, to be a scientific hub for research and development in space and advanced technologies. So one main goal behind establishing EAST is to build a knowledge-based economy and contribute in achieving the sustainable development objectives of the country. A few years later, in April 2015, Dubai government decided to incorporate EAST in the newly established Mohammed bin Rashid Space Center. So this slide here shows the vision and mission guiding MBRC to achieve its goals and future plans. So the vision of MBRC is to be recognized globally as a center of excellence in the field of space science and technological innovation, while the mission is to build a sustainable science and technology sector that contributes to the national knowledge-based economy through the launch and implementation of advanced space projects and prepare a generation of Emirati scientists to take our country towards a brighter future. So the MBRC team consists of approximately 200 administrative and technical staff. MBRC is characterized by having young Emirati engineers with an average age of around 27 years old. Furthermore, it is distinguished by having a high percentage of female participation in its projects, as 40% of its staff are female engineers. All right, so this slide here shows the UAE National Space Program, which consists of 4 main pillars that are the Satellite Development Program, Emirates Mars Mission, Mars 2117 strategy, along with the UAE Astronauts Program. So first, I will introduce the Satellite Development Program that actually aims at reinforcing the UAE capabilities in building Earth observation satellites and operating them effectively. Accordingly, the first satellite, that is Dubai Sat-1, was developed in collaboration with a SATRIC initiative, that's a Korean satellite company. So it was successfully launched in 2009, noting that the Emirati participation was 30% in this mission. A few years later, Dubai Sat-2 was launched in 2013 with an Emirati participation of 70%. In October 2018, the UAE fully developed satellite, that is Khalifasat, was actually successfully launched into its orbit. The second pillar in the UAE National Space Program, as I said before, is the Emirates Mars Mission, or what's called the HOPRO. It is the first probe to provide a complete picture of Mars' atmosphere and its layers. As you all know, the HOPE spacecraft launched successfully on the 20th of July 2020 aboard a Japanese rocket and arrived successfully in orbit around Mars on the 9th of February 2021. And now I'll shed some light on another vital initiative that is Mars 2117 strategy, aiming at actually establishing the first inhabitable human settlement in Mars by 2117. So in line with this strategy, the UAE will build a complex of buildings called Mars Scientific City. So it will comprise laboratories for food, energy, and water, agricultural testing, and studies about food security in the future. So Mars Scientific City will include a laboratory that will actually simulate the red planet's terrain and harsh environment through advanced 3D printing technology and heat and radiation insulation and so on. Another major component is the UAE astronaut program, so which aims to develop a national team of astronauts that can actually achieve the country's aspiration in taking part in scientific and manned space exploration missions. Okay, this slide here summarizes the MPRC missions in a form of a timeline starting from the BISAT-1 all the way to the HOPE probe. So as I said before, the BISAT-1 is the first UAE Earth observation satellite launched in 2009. The BISAT-2 is the second one, launched in 2013. In 2017, MPRC launched NAIF-1, which is the UAE's first nano satellite. It was built actually in collaboration with educational institutions. I'm talking here primarily the American University of Sharjah as a part of the Sustainable Space Science Knowledge Transfer Program. So the project actually helped to develop the skills of Emirati engineering students and provided them with hands-on experience in the design, manufacture, integration, installation, and operation of small satellites. 1 year later, in 2018, MPRC launched its third Earth observation satellite, as I said before, that's CalifaSat, and it's the first manufactured 100% by Emirati engineers in the clean room of our center in Dubai. On 25th of September 2018, Hazza al-Mansoori launched aboard the spacecraft to the International Space Station, ISS. During his mission, he conducted around 16 scientific experiments. 6 of these experiments were conducted in the microgravity to study actually the reaction of vital indicators of the human body aboard the International Space Station. On 20th of July 2020, Arabs witnessed a very, very big achievement by launching the HOPE probe to Mars. It helps actually in answering key questions about the global Martian atmosphere and the loss of hydrogen and oxygen gases into space over a span of 1 Martian year. All right, moving to something very, very important. Now let's discuss some key remote sensing terms. And the first and most important component of remote sensing is the energy source. So the energy is in the form of electromagnetic radiation. So it is either natural originating from the sun or earth by emission or by artificial means, in case if we have sensors that have that ability. So the electromagnetic energy actually refers to all the energy that moves with the velocity of light in a harmonic wave pattern. So electromagnetic radiation actually consists of an electrical field and magnetic field. So it can be defined as the energy propagated in the form of an advancing interaction between electric and magnetic fields. Actually, it travels with the velocity of light, if you remember the number of the velocity of light. Now, let's briefly highlight the concept of the electromagnetic spectrum shown in this slide. So the electromagnetic spectrum is composed of energy at different wavelengths. So the portion of the spectrum that we can see with our eyes is the visible spectrum, which is roughly between 400 all the way to 700 nanometers. It's worth mentioning that here the infrared portion of the spectrum contains longer wavelengths than the color red, and is quite useful when studying environmental features such as vegetation, since we need to know about the red and near infrared bands information wavelengths. So generally speaking, in GIS and remote sensing, the visible and infrared portions of the electromagnetic spectrum are the most widely used portions of the spectrum. As you all know, different objects reflect or emit different amount of energy in different bands of the electromagnetic spectrum. So the amount of energy reflected or emitted depends upon the properties of both. We're talking about the material and the incident energy. So detection and the discrimination of the objects or surface features is done through the uniqueness of the reflected or emitted electromagnetic radiation from the object. Also, it's worth mentioning that a device to detect this reflected or emitted electromagnetic radiation from an object is called a sensor, as shown here, while the vehicle used to carry that sensor is called a platform. We can call it aircraft, you can call it satellite, and so on. And now let me summarize the remote sensing process for you. So as you all know, we first need an energy source, as a sun, for example, so that it can provide electromagnetic energy to the area of interest. If we need to capture, or we need to capture a certain area on Earth, so we need that source of energy that can provide an electromagnetic energy to that area. As energy travels from its source to its destination, to our region of interest, it can communicate with the, let's say, atmosphere it passes through. When the energy moves from the target to the sensor, a second interaction can occur. As energy passes through the atmosphere and reaches the target, it actually interacts with the target based on the properties of both, as I said before, the target and the radiation we have. So once the energy has been emitted from the target, the sensor will collect and record the electromagnetic radiation, and the sensor energy must be transmitted, usually, as you know, in electronic form to a receiving and processing station. So the data is then converted into an image, either hard copy or digital. And as we reach to that point, let me show you some of the images received by our ground station at MBRC, and these images are for Dubai Sat 1, Dubai Sat 2, and Khalifa Sat. Well, here are some images captured by Dubai Sat 1 with a spatial resolution of 2.5 meter. So it can be used for monitoring natural resources and contributing in disaster management. Moving to DubaiSat-2, so the spatial resolution of DubaiSat-2 is 1 meter. It is very effectively utilized to study the natural phenomena related to environment. KhalifaSat is the best in terms of the spatial resolution. So I'm talking here about 0.7 meter. All of these satellites are similar in the spectral bands. So we are talking about 4 spectral bands that are red, green, blue, and near infrared. Okay, so such Earth observation data are very, very efficient for urban planning, projects monitoring, land use, land cover mapping, or what's so-called classification, oil spill detection, environmental analysis, disaster management, and many, many more. As shown in this slide, the United Nations listed 17 Sustainable Development Goals, the SDGs. And it is worth mentioning that Earth observation is an innovative and accurate approach to address the indicators associated with the Sustainable Development Goals. It's worth mentioning that the 40% of these goals are contingent on the use of the space technology and Earth observation data. Actually, when we are talking about Earth observation data, these data are the oil of the 21st century. We're talking here about big data. So we need to think of how to deal with such a data in terms of the pre-processing. We have a huge data, how to pre-process all of these data, how to filter it, how to do the data processing, how to do the post-processing, how to do this, how to store this data, how to archive it, how to analyze it, and how to share it, and how to do some kind of a data fusion. So we need to think of all of these terms when we are dealing with a big data. This is something very, very important. And now let's have a look at some MBRC value-added products and services. So I'll begin by providing some examples of environmental studies conducted using the MBRC Earth observation satellite imagery along with data from other sensors. So we carried out various projects related to water resources, such as, for example, monitoring water levels in dams throughout the seasons, monitoring the changes that occur to the coastline throughout the years. And as you know, that such kind of analysis is extremely important and extremely necessary for different governmental entities here in the UAE, like the municipalities and along with other environmental entities, to actually analyze the changes, to be able to take some actions in advance to encounter any future crises. Moving to the third example here, which is detecting underground water using the synthetic aperture radar technology. So in this study, we use what's so-called the data fusion between DubaiSat-2 and ALOS-2 from JAXA to identify the potentiality of having underground water in Khat area in Ras Al Khaimah. Okay. So disaster management is another area of interest to MBRC and to all the Earth Observation Society. So MBRC is a very, very active member of disaster management organizations such as Disaster Charter and Sentinel Asia, as we provide them with high resolution satellite imagery along with analytical reports and maps for the areas that actually witness crises such as earthquakes, volcanoes, flooding, storms, and so on and so forth. So here are some examples of the maps provided to Sentinel Asia showing the detected flood water in Japan. Here are other examples of the floods in India and Indonesia, which took place in July 2020. We provided Sentinel Asia with an analytical report related to the Beirut port explosion as well. We also provided them with the interferogram related to Philippines earthquake as shown in this slide. And there are many more of studies in this domain. Okay, so now we have come to a very interesting chapter for most of us when AI meets with artificial intelligence and remote sensing. As you all know, artificial intelligence is a hot research topic nowadays, and it is crucial to handle Earth observation data. So machine learning has been found many applications in remote sensing, and these applications range from retrieval algorithms to bias correction, from code acceleration to the detection of disease in crops, from classification of habitats to rock type classifications, and many more. So as a broad subfield of artificial intelligence, excuse me, machine learning is concerned with algorithms and techniques that actually allow computers to learn by example. And this is very important here. So the major focus of machine learning is to actually extract information from data automatically by computational and statistical methods that we all know. So over the last decade, there has been considerable progress in developing a machine learning methodology for a variety of earth science applications involving the trace gases, retrievals, aerosol products, land surface products, along with vegetation indices, and most recently we need to talk about the ocean applications also as one of the recent applications in this regard. So artificial intelligence, machine learning, and deep learning have become the most talked about technologies in today's commercial world, as companies around the world are using these innovations to build intelligent machines and applications. And although these terms are dominating business dialogues all over the world, many people have different, or they are actually have some difficulty differentiating between these three terms and terminologies. So here is an illustration designed to help you understand the basic fundamental differences between artificial intelligence, machine learning, and deep learning. So now let's begin with the artificial intelligence. So as you all know, it's the process of imparting data, imparting information and human intelligence to machines. So the main goal of artificial intelligence here is to develop self-reliant machines that can actually think and act like humans. So these machines can mimic human behavior and perform tasks by learning and solving problems. So most of the AI systems actually simulate natural intelligence to solve complex problems. This is very important. And while machine learning is a subset of AI, as shown in this graph, and it is a discipline of computer science at the end of the day that actually uses computer algorithms and analytics to build the predictive models that can solve business problems nowadays. So machine learning here actually accesses vast amounts of data, both structured and unstructured data, and learns from it to predict the future. So it learns from the data by using multiple algorithms and techniques. But if we move to the deep learning, we are talking about a subset of machine learning that actually deals with algorithms inspired by the structure and function of the human brain. So deep learning algorithm here actually can work with an enormous amount of both structured and unstructured data as well. So deep learning core concept lies in artificial intelligence networks. So we're talking about a very, very huge neural network with different hidden layers and many, many hidden layers and nodes and weights and so on, which enable actually machines to make decisions, to make right decisions. It's very important. All right, so the major difference between deep learning and machine learning is the way data is presented to the machine. So machine learning algorithms usually require structured data, whereas deep learning networks work on multiple layers of artificial neural networks. Okay, so this slide here summarizes the main differences between AI, machine learning, and deep learning. And before jumping to the applications, let me shed some light on the commonly used machine learning methods and techniques. Okay, so the widely used approach, as you all know, is the artificial neural network, ANN. As shown, it consists of a node layers containing an input layer, one or more hidden layers. So we have two hidden layers in this graph in front of us, and an output layer at the end. So each node, or sometimes in some literature and some papers called artificial neuron, connects to another and has an associated weight and threshold. So we need to do what's so-called the forward propagation and backward propagation in order to calculate these weights and threshold. So if the output of any individual node is about the specified threshold value, if we have, for example, a certain value, then that node is activated. And this actually means that if it is activated, then it will be like sending data to the next layer of the network. So it will allow data to go to the next layer of the network. Otherwise, what will happen? No data is passed along to the next layer of the network. All right, so in general, neural networks rely on training data to learn and improve their accuracy over time. However, once these learning algorithms are fine-tuned for accuracy, they are powerful tools in computer science and artificial intelligence that actually allow us to classify and cluster data at a high velocity. All right, so tasks in recognition, we are talking here especially about image recognition, for example, can take minutes versus hours when compared to the manual identification by human experts. So one of the most well-known neural network, as you all know, is Google search algorithm. All right, so now let's have a look at some remote sensing applications based on machine and deep learning. Nowadays, we are developing a model at MBRC and MBRC Lab to detect palm trees from aerial imagery. And here are some initial results from our model. Last year, we developed a couple of models to detect various objects, such as ships with the help of deep learning, airplanes, electric towers, cloud, along with cars, if we have, of course, aerial imagery and aerial data. AI can also be utilized to automatically detect changes in a particular area throughout the years, as shown here. So we will be able to identify actually the changes that occur to our infrastructure features especially here if we are talking about the vegetation, the water bodies, buildings, road networks, and undeveloped areas, along with the buildings, of course. Okay. Also, we can detect oil spill using deep learning, but it's not an easy and straightforward approach. We need to take a lot of factors into consideration while we are dealing with this problem. Okay, so sometimes we need to do on-site survey to collect data and generate products through using drones, for example. So we conducted a study to investigate the impact of rainfalls on the mountains surrounding Hatta Dam in Dubai in order to analyze if there is any risk encountering the nearby villages, farms, and homes. So to do so, we generated an orthophoto for the area of interest. And this is the orthophoto for that area. Along with that, we generated a very accurate digital elevation model. It's called DEM, and a 3D model for that area. Okay, let me run this video for you. So this video here shows our final outcome related to the 3 model analysis for Hatta Dam, where we use the orthophoto and overlaid with the digital elevation model. And by actually using some GIS softwares, we are able to produce this video and this analysis and provide it to our end user. Okay. So finally, we used ArcGIS to generate what's so-called the hydrological model to obtain the water flow direction in case of rainfalls on that area. And most of these water actually going to the dam with no risk on the nearby villages, farms, and buildings near to that area. This slide here shows the entities and academic institutions collaborating with MBRC on regular basis. And here our distinguished end users that we are proud to serve. Yep, so this is the end of my presentation, and thank you so much for your attention.
Thank you very much, Engineer Saeed, for your informative and beneficial presentation. It is time for our audience to participate. You may ask questions and feel free to raise your hand if you have any other inquiries as well. Saeed, we have a question with regard to the use cases.
Yes, from our colleague, Mr. Mustafa, is asking what are the priorities of the use cases. So here, when we are talking about the use cases, as you know, we are at Mohammed bin Rashid Space Center. We do have the business development team where we are meeting with our customers on regular basis. So we are meeting with them and we are collecting their requirements. After that, we are sitting together as a team with the business development along with the applications development and analysis section. We are meeting together to discuss their needs and requirements and trying to convert their needs into technical questions, and then doing some literature review from our end to fulfill the requirements to make sure that we are able to conduct their case studies or conduct their applications and so on. And after this case study, we are arranging the technical meeting with that entity to make sure that we are all on the same page, and if we are able to do it, we are start doing it. How to increase the level of use of remote sensing data and AI for the government entities. How to increase the level of use. Yeah, we can increase the level of use of remote sensing and AI by actually applying what is so-called the data fusion. So, and also we can get data from different governmental entities. So it's not just MBRC that provide data. So we can get also some data from different governmental entities and do what's so-called the data fusion with our data from the BISAT-2 and Khalifa Sat, and try to maximize the data that we have and try to get the analysis done. There is one question from Reem Al Ali, our new researcher at MBRC Lab, about the ANN threshold value is the first. You mentioned that the threshold value in the first node step. How do you specify the value? And can you explain more about it? Okay, as you all know, when we are talking about artificial intelligence, we are talking about different layers. We are talking about the input layers where we need to feed the neural network with our training data. Then we will have the hidden layer, and we need to be very careful when we are dealing with the neural network, and especially with the hidden layers. We need to define the number of the hidden layers based on a certain criteria. So the best way to do that is to do the forward propagation and backward propagation to be able to actually define these numbers. So we need to define all the weights, we need to define all the threshold, and at the beginning we need to put some initial value for the bias. So some people, they are putting bias as a 0, some people, they prefer to put the bias as a 1, and then after the forward and backward propagation, after coming and going, we will be able to actually fine-tune these values and parameters until we are getting the best values, and we will have the less error in our neural network. So this is the perfect way in dealing with the artificial intelligence when we are developing the hidden layers ourselves. There is another question. What is your advice related to? Sorry, Alia?
We have a question from Najma as well. Do you have online platform using the remote sensing analysis?
Yes, for sure. We do have our own platform where you can find all our analysis and all our applications there. We can send you the link of this platform, so that you will be able actually to enjoy learning about our analysis. It's called the GeoAnalytics. It's called GeoAnalytics platform. You can search on the internet. You can write GeoAnalytics MBRC, and you will find a brief about the GeoAnalytics. And there are also 3 story maps for different studies that we conducted at MBRC.
We will share the link as well in the public chat. We also have a question. What is your advice related to creating standards for imagery data?
What's the advice related to creating standards for imagery data? Yes, so as you know that you need, when you are talking about the imagery, when we are talking about such kind of data, we need to know that there are different spatial resolution. We are talking about different spectral resolution, about the quantization, and this is something very important. As you know that there are different quantizations. There are 8-bit quantization, 10-bit quantization, and so we need to make sure that whatever database that we are creating or what we're having, so it is all of the same quantization level. It's all of the same spectral band. It's all of the same spatial resolution, so that it will not affect. When we are coming to feed our deep learning model or machine learning with this data, in order to make sure that what we are getting at the end of the day is something very, very tangible, and we will get very high accuracy at the end of the day.
I believe that's it for today. Thank you, Engineer Saeed. We come to the end of today's webinar. Thank you all for your kind interest in attending, and we look forward to have you in our upcoming events, hopefully, inshallah, soon.
Thank you so much.
Thank you very much.